Welcome back to medical physics. Today we are going to discuss about interaction of radiation with matter. All the particulate and electromagnetic radiation can interact with the atoms of observer during their passage, producing ionization or excitation in the observing atoms. These radiations are called as ionizing radiation because the particulate radiation they have mass, electromagnetic radiation they do not have mass. The latter, that is the electromagnetic radiation, travel through matter for a long distance before losing all of its energy. So electromagnetic radiations are therefore called as penetrating radiation and particulate radiation are called as non-penetrating radiations. The radiation which are interacting with the matter can be either absorbed or scattered. Mechanism of absorption of radiation are more important because the absorption of radiation in the body tissues may result in biological injury. Absorption is the basic principle for the detection of radiation. The degree of absorption is the primary factor in determining the proper shielding requirements. The transfer of energy from excited radiation to matter occurs in two major ways, either ionization or excitation. What do you mean by ionization? The process resulting in the removal of electron from the atom, leaving the atom with net positive charge. This process is called ionization. What do you mean by excitation? The addition of energy to an atomic system, transferring from its ground state to excited state. That is called excitation. Here no ion form is formed, but the energy which is given off by the atom as a fluorescent radiation or low energy X-ray when the atom returns from higher energy level to lower energy level. Kronkov radiation. When the charged particle travel through the medium at a speed is greater than the speed of light, they can polarize the molecules in the medium, which then turn back rapidly to their ground state by emitting the radiation. The emitted radiation is in bluish in color. This is called a Kronkov radiation. The Kronkov radiation, the light produced by charged particle when they pass through an optically transparent medium at a speed is greater than the speed of light in the medium. Devices which are sensitive to this particular form of radiation are called Kronkov detectors have been used extensively to detect the presence of charges of atomic particles moving at a speed of light. So there are three important parameters when the charged particle interact with uh, matters. First one is specific ionization. Second one, linear energy transfer, and third parameter is range of the particle. Specific ionization. What do you mean by ionization? The ionization is nothing but with the help of the external radiation, we can create positively charged atom and negatively charged electron. So this process, which is possible with the help of the external radiation. So now we discuss about specific ionization. The specific ionization which is used to compare and relate the ionizing power of the different types of charged particle. So this parameter is called a specific ionization, which is defined as the number of ion pairs formed per unit length formed by ionizing radiation in the medium. Mathematically, specific ionization is equal to number of atoms formed or number of ions formed per path length. So, what are the parameters which depends upon the specific ionization? So, the specific ionization which is depends on velocity of the charged particle, mass of the charged particle, charge nature of the particle, and density of the absorbing material. So the specific ionization increases with the decreasing energy of the charged particle because It increases probability of interaction at low energies. And next parameter is linear energy transfer. So the linear energy transfer is nothing but the amount of energy that an ionizing particle transferred to the material per unit distance. It is identical to the retarding force acting on the charged ionizing particle travel through the matter.